This is question number 63 from book number 1 based on the 2020 NEC, and this is electricaltime.com. What is the minimum rated general use switch in amps that is inside of the gas furnace that has a blower motor of 1/4 horsepower at 120 volts, single phase? For the purpose of this question, assume that the wattage required by the electronics of the gas furnace are negligible. Just focus your answer on the blower motor. And we have a couple of answers here. We have A at 5.8 amps. Then we got B, 7.25 amps. Then we got C at 11.6 amps. Then we have D at 13.3 amps. Just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video. And the answer to this question is going to be C, and that's going to be 11.6 amps. And again, we're looking for something called a general use switch. And we're determining, what that minimum ampacity of the switch has to be. And that switch has to be in sight of the gas furnace, in our example, and that the blower motor is 1/4 horse power at 120 volts, single phase. So looking at this, I'm going to say that we are talking about motors, and that is going to be Article 434 motors. And most likely we're not looking at the article for appliances, which was Article 422. And that's because in the question, I'm asking you just to focus on the blower motor. And by doing that, I'm sort of telling you that we're going to be looking at motors, which is going to be Article 430. All right, so Article 430 for motors is within Chapter 4, and that's called Equipment for General Use. And then we look at all the parts, and there's a lot of parts in Article 430. So make sure that you really know about all the different parts. Otherwise, you're just going to be wasting a lot of time. And we find Part 9, which is called the disconnecting means. And again, we're looking at that general use switch as a disconnecting means, and that's why I'm picking Part 9 for disconnecting means. Then we find 430.109 type. Then we find 430.109C, and that talks about stationary motors of 2 horsepower or less. Then we find 430.109C1, and that tells us for the general use switch that we're going to be using the minimum of 2 times the FLC, and that's going to stand for full load current. All right, so step number 1. We're going to go to 430.109C, the disconnecting means, in our code book, and it talks about stationary motors of 2 horsepower or less, and it says that if the stationary motor is rated at 2 horsepower or less and 300 volts or less, that the disconnecting means can be one of the devices specified in 1, 2, or 3. So step number 2. Let's go to 430.109C1, and it says that if a general use switch is used, the minimum amp rating is going to be at least 2 times the full load current, and we call that the FLC rating. Step number 3, let's go to table 430.248. FLC, again, that's for full load current for single phase AC motors, and look in the first column and find that the motor with 1/4 horsepower, and see that 115 volts gives us an FLC, and again, that's for full load current of 5.8 amps. All right, and let's take a look at table 430.248, and here it is. All right, so before we go on with this, I just want to mention something about something called the NFPA link. It's having the code book on your cell phone. It is absolutely fantastic. I highly recommend it. And you can get this directly from the NFPA by going to the website nfpa.org. All right, so this is table 430.248 and it's called full load current in amperes, single phase alternating current motors. And up on top, we've got the horsepower over here. Then we've got the 115 volts, 200 volts, 208, and 230 volts. All right, so again, we're looking for that size of motor that we have in our question. And that was a quarter horsepower. So there it is over there. And at the intersection of a quarter horse and 115 volts, we've got 5.8 amps. But you might be saying, Steve, hey, that question, said that it wasn't 115 volts, it's 120 volts. I know. I'm just as confused as you are on this, but that's just the way it is. This is the way the code book has it. And again, that's just the way it is. All right, so you can ask your electrical inspector or instructor why the code book has not recognized 120 volts. And I do believe it has to do something with the rating of the actual motor and not the actual precise voltage that's coming from our utility company, which we know it can go up and down based on the load that is on the utility company's electrical system. All right, that's the best answer that I can give you. All right, so again, we go to this table, 430.248 for the full load current in amps, single phase alternating current, and we find out that a quarter horse power motor at 115 volts is going to be equal to 5.8 amps. And you're not going to be looking at the nameplate of this motor, which we also call the FLA. The code book is telling us that we have to look at this table 430.248 to determine the minimum ampacity for that general use switch. And again, a quarter horse is going to equal to 5.8 amps. So let's go back in our textbook and see what we're going to do now. So step number 4, 430.109C1, the FLC of the motor is 5.8 amps times 2 is equal to 11.6 amps, and that's going to be our answer. Again, the answer is C, and that's 11.6 amps, and that's code reference 430.109C1.